Everybody, welcome back. We are still in the second half of our trigonometry unit. Last lesson we looked at the area of a triangle when it was not given to us that we had an altitude. So for example, you have all three sides, all three angles, what's the area of the triangle? If you don't know the altitude, you are not able to figure that out. Whereas when we use the trig version of the area formula, we are able to do that as long as we have a side angle side situation. Okay, so for today, we're going to be moving into a new formula that goes with non-right angle triangles. And this is going to be one of the methods we're going to use for solving for missing sides or angles when it's not a right angle triangle, so SOHCAHTOA it doesn't work, and we don't have another way of figuring out a missing side or angle. So this is one of the two laws that we're going to learn, and it's called the law of sines. So the questions are going to be the same for today and the next lesson because it's really the same kind of question. Like, you are presented with a situation, which formula do I need to use to solve for the missing side or missing angle? How do I know which one I need to use, and then how do I use it? Okay, so law of sines. Very simply, you're going to be presented with some situations like this. And law of sines is based on the idea that a side and the angle opposite it are going to have a proportion, and that proportion is going to be the same as any other side and the angle across from it. And what we're going to be looking for is this idea of we want pairs of sides and angles that we know that are across from each other. So if you can find a relationship like that, where you know an angle and you know the side across from it, law of sines is going to be something that we can use. So we need this pairing to create our proportion, and then we can base another proportion off that. So like, say we could solve for y using the 80 degrees or x using the 60, because we have one of those pairs where we know both elements. Let's take a look at the formula and see how it's built. So here's your formula. It looks kind of confusing at first. It's actually not that bad. Basically, what we found, or say we mathematicians found, is that if you take the sine of an angle, so say sine of angle A, and you divide it by the side across from it, so again talking about that pairing across, it creates a proportion, and you get the same proportion if you take the sine of another angle divided by the side across from it. So in this case, like, you usually discount one of the equal signs. Like, you're never seeing an equation with two equal signs. It's always just going to be one proportion where you know one pair and something in the other pair is missing, either the angle or the side, and then you go to solve for it. So which version? These are the same formula, by the way, just different versions. So we could rearrange the top formula to look like the bottom one, but typically it's easier for us to solve for a variable when it's in the numerator, so above the fraction line. So if your missing piece is an angle, it means that we're going to put the sine of the angle on top of the fraction and put the known side underneath it. Same thing if you don't know the side. So you're solving for missing side, we'll put the side on top and we'll do sine of the known angle underneath of it. And that just makes life a little bit easier when it comes to solving for one of these missing pieces. Let's take a look at where this formula comes from. All right, so we're kind of back to this familiar triangle again. It's a generic triangle. You got angles A, B, and C, and you got sides A, B, and C as well. And I drew in the altitude h here just because we need it in this proof. So the only thing we know about it is that it's an altitude h. We don't know what the value of it would be. We're assuming that in a generic triangle like this, it wouldn't be given to you. So it's not part of our given statement, something we introduced. So the given is triangle ABC. So it's a triangle ABC. The corners are A, B, and C. The sides are lowercase a, lowercase b, lowercase c. This is our given. So to start us off, this is a partial proof, kind of give us a hint where to go. Sine of angle A, it's going to need opposite and it's going to need hypotenuse. So this is our right angle that we're talking about on the left here. So remember, SOHCAHTOA only applies to right angle triangles. So sine of angle A is the opposite h over the hypotenuse b. Sine of angle B Opposite is still h. Hypotenuse, however, is a. So this would be h over a. So this is just based off of SOHCAHTOA. You could also say sine ratio, it would be fine. But as long as you're kind of giving an indication that you are using a reasoning behind why you pick sine and why you use those two sides. All right, so like the last formula with area, h is not part of our given information, so we can't use it in our formula, so we're going to try and replace it. So in both of our equations that we came up with, we want to try and replace h, so we want to isolate it, get it on its own. To get h on its own in the first one, we're going to have to multiply by b on both sides. So we would get b times the sine of angle A is equal to h. And that's just multiplication property. Of equality. Same thing on the second one. If we multiply by a on both sides, so the b's cancel up here, a's cancel down here. So we get a times sine of angle B is equal to h. And we got multiplication again. So now, both of these equations are equal to h. And it's the same question, so that means those two h values are equal to one another. So hopefully you guys are familiar with this by now. If two values, so think of our example, if a equals b and b is also equal to c, then a must be equal to c. This is called our transitive property, or we could also call it a substitution, whichever one you want to go with. But the idea here is they're both equal to h, so we can make the two of them equal to each other. So we say b times sine of a is equal to little a times sine of b. So this is my transitive property. Now, I'm not done. Remember, our proof statement is this formula, and really we're ignoring the c part at the moment. We're just working on a and b. So I need to get this a little more tidied up. So if I want to get sine a on its own in the numerator, the b has got to go. So I'm going to divide by b on both sides. On the other side, I want to get rid of the little a, so I'm going to have to divide by a on both sides. So on the right, the a's will cancel. On the left, the b's will cancel. And then what's left is sine a over a is equal to sine b over b. And there you go, that's it. And if we'd done the same thing with angle C, it would have worked out the exact same way. So we just would have needed a different altitude. So say like if this had been my altitude, we could very easily get the same proportions for C. Or if we had said at this row that we want to get the sides on their own, we would divide by sine B and sine A on both sides. They would cancel, and we would just end up with the other version of our formula. So this was multiplication property. Now, just in case my handwriting is not legible, I did a typed out version as well. Let's take a look at it. So exact same stuff, isolating, sort of writing sine A and sine B to involve h, isolating h, substitute a transitive property, then getting rid of the extra variable and putting it underneath the fraction. So that's where our formula comes from. So it's proving that there is this proportion between the sine of an angle and the side across from it is equal to the sine of another angle and the side across from it. And that's going to be important for us now to be able to solve for one of those missing pieces. All right, so here's our example. We've got triangle with 80, 60, and 40 degrees, and one side is given to us. What we notice is that we can do this little arc that involves a side and its opposite angle, and we know both pieces of information. So this, in my head, is the tick box to say, oh, this is a law of sines question. It's not Pythagoras' theorem because there's no right angle. You can't use SOHCAHTOA because there's no right angle. So now you're saying, all right, I've gone through the easy ones. Law of sines is up next. And then to solve for x, x is a side. The angle opposite is 60, so that's going to be my other pairing. And I'm solving for a side, so I'm going to use the version of the formula where the side is on top. So that would be a over sine A is equal to b over sine B. So in our case, you always put the information you know first, so that's kind of your reference. So it's going to be 10 over sine of 40 degrees is equal to x over sine 60. All right, now it's an algebra problem. We want to get x on its own. Sine 60's got to go, so we multiply by sine 60 on both sides. So our final answer is going to be sine 60 times 10 all over sine 40 is equal to x. So at this point, we're going to go to our calculators to calculate this out. Bear in mind, you need to close that parenthesis after sine, because if you do sine 60 times 10 without that closed parenthesis, it will do sine of 600 for you, which is not the same thing. So sine 60 closed parenthesis times 10 divided by sine 40. So sine 60 times 10 divided by sine 40, we get x is 13.47, and we're rounding to the nearest 10, so that'll be 13.5 is equal to x. All right, then you just move on to y and you do the exact same thing. So 80 and y is our final pairing. I always go back to the information I know just in case I made a mistake calculating x, plus we rounded it. So if you use a rounded answer as your kind of basis for a proportion, then the other answer is also going to be off. So go back to the numbers you know. 10 over sine 40 is going to be equal to y over sine 80. Multiply by sine 80 on both sides. So we get sine 80 times 10 divided by sine 40. So you can see like it's pretty repetitive. You just have to set it up correctly and then off you go. So let's take a look at what that is. All right, so if we do sine 80, close it, times 10 divided by sine 40, we get 15.32, which rounded to the nearest tenth is 15.3 is equal to y. Now, one thing I want you to do before you finish is to just kind of double check your work. So x is 13.5 and y we said is 15.3. Based on how triangles should look, the biggest side should be opposite the biggest angle. 15.3 is the biggest side, 80 is the biggest angle, that checks out. 13.5 is bigger than 10, so 13.5 is my middle side. 13.5 is opposite the middle angle 60, so that checks out. 10 smallest side, opposite smallest angle, so they all check out. And that's just one way to make sure that your answers are looking the way they're supposed to look. And we'll see in a couple of minutes why that's an important thing to do. Okay, here's the second example. This time, the angles are missing. So looking at it, we've got that pairing, the 5 and the 25 are the side and the opposite angle that we know. And then we've got an angle A and we've got an angle B. There is something I want to show you guys, and it's going to be an incorrect answer, but I want to show you it anyway to show you why it's incorrect. We're going to solve for angle B first. So just like say I was picking one, I'm like, all right, I'm going to solve for B first. So we're solving for an angle this time. So that means angle version of the formula is going to go on top. So sine A over A equals sine B over B. You can solve it the other way. It's just a little bit more multiplying to get the variable above the fraction and then solve for it. So this would be sine of 25 divided by 5 is equal to sine B over 11.81. All right, so we've got sine b, we want to get on its own. One thing to point out, and it's kind of like a note to self, sine 25 divided by 5, a big mistake I see people make is to think, oh, I can divide the 5 and that 25 and it just ends up being sine of 5. Not true. Sine is a function. 25 has to go through that function before it can be added, subtracted, multiplied, whatever it is. So just keep that in mind. All right, so to get sine b on its own, we eventually want to get b on its own. But to do that, we're going to have to get rid of the 11.81 and then the sine part. So multiply by 11.81 on both sides, that'll get rid of that. So we get 11.81 on the left as well. So that means we're going to have 11.81 times sine of 25 all over 5 is equal to sine b. Remember how to get an angle on its own? You're going to multiply by the inverse function. So sine inverse of sine cancels out, and we're left with just b. So b is equal to sine inverse of 11.81 times sine 25 divided by 5. And notice that my parenthesis goes all the way around it. That whole side of the equation is inside of that sine inverse function. So let's put that in our calculator to see what we get. Okay, so how I do this, I do 11.81 times sine 25. It's 4.99 ... divided by 5, and I'm getting inside this parenthesis 0.99822. I don't really want you writing this step out. I'm just doing it for you because at this point I would be rounding. I'm going to leave it in my calculator and then carry it through. But one thing to note, if you are doing sine inverse or cos inverse of, to solve for an angle, this number needs to be between 0 and 1. And there is technically a way that it can be negative. We will get to that very soon. But for now, between 0 and 1. The negative version would be between -1 and +1 is the true values it can be. All right, so we do sine inverse of our answer, and I get 86.58 degrees. And round to the nearest tenth, that would be, so angle B equal to 86.6 degrees. Okay, that looks pretty reasonable, right? So that plus 25 would be 111, and if we take that away from 180, we would get 68 degrees is angle A. So what I did was I said, I have 3 angles. I know angle B is 86.6 degrees, and I know 25 degrees. So if I take those away from 180, I'm left with 68.4 degrees. Just put that 0.4 in there. Which we're like, cool, that makes sense. But let's just check our work just in case we made a mistake. So what we're going to do is we're going to solve for angle A using law of sines, just in case. So we will go back to this 25 and 5. So that'll be sine 25 all over 5 is equal to sine A over 11. Same process as last time, multiply by 11 on both sides. And then we do sine inverse of all of it. So we're going to get sine inverse of 11 times sine 25 all over 5 is going to be equal to angle A. Go back to our calculators. So we're going to do 11 times sine of 25 and then divide that by 5. So I'm getting 0.92976 and then second function sine for that. So it's going to be 68.39 degrees. Which checks out. Looks good, right? So we're like, cool, this is fine. And actually I'm realizing it's the next example I need to show you where there's going to be something wrong with that. So we're good with this one. Both worked out, law of sines, good to go. this one is the one I want to kind of talk more about. So solve for the two angles using law of sines. Let's go for it. Let's start with angle B. So again, I want to demonstrate to you if we choose to go with the largest angle first. And I know it's the largest because it's opposite the largest side. So the pair we know is this 18.79 and angle A, or I'm sorry, the 10 and the 20. Let's ditch that. There we go. So solving for an angle, let's go on top. Sine 20 degrees divided by 10 is equal to sine B over 25.32. So we multiply by 25.32 on both sides. So we're going to get 25.32 times sine 20 divided by 10, and then we're going to have to do sine inverse of both sides to get angle B on its own. So I'm just going to kind of throw that in here. Sine inverse, there's going to go. So it's going to be sine inverse, big parenthesis, 25.32 times sine of 20 degrees all over 10. And this is equal to angle B. All right, so we got 25.32 times sine of 20 divided by 10, and then we do sine inverse of that answer. And I got 59.99 degrees, and that's 996, so really when we round this, it's 60 degrees. Okay, 60 degrees, that works. So if angle B was 60 degrees, and this angle down here is 20, angle A, so 60 plus 20 is 80, subtract 100 degrees, angle A would be 100 degrees. But that can't be right, because B should be a bigger angle than A because it's opposite the largest side. So this is what I was trying to point out the last time, that the largest angle is a potential problem. And the problem here is that angle B is actually obtuse. So it's when you are doing an obtuse angle, so an angle greater than 90 degrees with law of sines, there is this weird situation that pops up. Let me try and explain. So start again. So the issue here is when you do law of sines, or when you do sine of an obtuse angle, it actually gives you the same answer as an acute angle. And it's a little, you'll really dig more into this in Algebra 2, but here it is for the sake of argument. So we've got a point at the center, and this is what we call a unit circle. So you imagine a circle, and all around it, the radius is equal to 1. And it's on a coordinate plane. So this in the center here is 0, 0. And this would be 1, 0. And this one would be 0, 1, and negative 1, 0, and so on. So if we think about an angle, angles are measured, I'm going to actually do this in a different color just to make it easier to see. So angles are measured from the x-axis going counterclockwise. If you are doing sine of an angle, you are doing the opposite. So that would be the y-coordinate, because you think of this as a point. So if it's a point xy, y-coordinate is the height, x-coordinate is the width, and then the hypotenuse is 1 because we said this was a unit circle. So if we do sine of this angle, y is a positive number, 1 is a positive number, and we get sine of a positive number is going to be the particular angle we're talking about. If you go over to the second quadrant, remember this is second quadrant, this is first quadrant, third's down here, fourth down here. If you go into the second quadrant and say, we go over here to minus xy. So it's a reflection across the circle. The hypotenuse is still 1. The height of this triangle is still y, so both are still positive. It looks like the exact same triangle to your calculator, but really we are trying to do now this angle. So what's happening is that if we do an obtuse angle, it will give us back the acute angle by default. The calculator thinks we want the acute angle. So one thing you're going to have to think about is, all right, how far is it from 90 degrees? It'll be the same distance on the other side. Or, what's the distance back from 180? It's hard, but it's not something that takes a while to get your head around if you kind of give it a chance. What I'm going to recommend to you, though, that when you come up with a situation like this, you're always going to solve for the not going to solve for the largest angle first. So what you would do in this case is you would say, I know B is my largest angle because it's off to the largest side. I'm going to avoid that one. I'm going to solve for A first. Reason being, in a triangle, you can only have one obtuse angle. So if I solve for A, that gets me an angle that I know can't be obtuse because B is the only one with the potential to be obtuse. And then I can do triangle sum theorem, so I can subtract to get my angle B. So just be on the lookout for that. Biggest angle has the potential to be obtuse, which can throw off your numbers. By sticking to the non-obtuse angle and solving for that, and then saying, okay, we can combine these and figure out angle B, we can solve for that. So if we do a quick sketch of what that would have looked like, it would have been sine 20 over 10 is equal to sine A over 18.79. We'd multiply by 18.79 on both sides. And then we do sine inverse of all that as well to get A on its own. So it would be sine inverse of 18.79 times sine 20 all over 10 is equal to angle A. So pulling out our calculator, 18.79 times sine of 20 divided by 10, and then we're going to do sine inverse of all that, and we get 39.99, so 40 degrees. So if this is 40, well then 40 plus 20 is 60. 180 minus 60 is 120 degrees. So that was the big difference. I think we were coming up with 60 degrees from the last one. So when we solved the law of sines, we got 60. So think about it. We've got 60 degrees, 120 degrees. So 120 degrees and 60 degrees. Both of which are 30 degrees from 90 or 60 up from the x-axis, depending what way you want to talk about it. So just be on the lookout for that. Rule of thumb, solve for the smaller angle first. All right, take a look at this word problem. Let's see if you can solve it. So two surveyors are on a mountain. They're 10 miles apart, and they want to figure out the height of the mountain. So pause the video, take a shot at it, see can you do it. All right, so they're 10 miles apart. We've got 53 degree angle, 30 degree angle. Just because it's good to have information, let's figure out that last angle. 53 plus 30 is 83. So that means our missing angle is 97 degrees, not a right angle. So even though it's close, it's not a right angle. So we're going to need to figure out the height of the mountain. So the height of the mountain is going to be that perpendicular height or altitude. So we need to figure out the distance from AB to C at a perpendicular angle. So that's what we're looking for. How you'd approach this, you're going to figure out, this is what we're after. We're going to figure out this guy, and then we've got a hypotenuse, and we want the opposite using angle 53 degrees. So we're going to be able to use SOHCAHTOA to finish this question off. To find x, though, it's going to be a law of sines question. So we're going to have side and angle we know, 30 degrees and x. All right, so let's set it up. We're solving for a side, so sides are going to go on top. 10 over sine of 97 is equal to x over sine 30. We want x on its own, so we're going to multiply by sine 30 on both sides. Bonus points if you remember what sine 30 is from our special right triangles. So really you could figure this one out a little bit easier. So we got sine 30 times 10. So we get 30 times 10, and then divided by sine of 97. So that is 5.03. So 5.03 is x. So we've got a small right angle triangle with an angle of 53 degrees and a hypotenuse of 5.03. Actually, it's 0.37, so we'll go 5.04. And we want h. So that's a sine function because we have opposite hypotenuse. So back to SOHCAHTOA, sine 53 is equal to opposite over hypotenuse, multiply by that 5.04 on both sides. So 5.04 times sine of 53 is equal to our height. So 5.04 times sine of 53, and we get 4.02. So to the nearest mile, that would be 4 miles high. So the altitude of this mountain is 4 miles. That's it. All right, so for you guys, you have some bookwork to do. I've posted the PDFs in Schoology. So there's page 631, questions 4 and 5, page 634, questions 1 through 14, and then 19 through 21 is, I think, on page 636. Just leave out 15 through 18, just extra questions we didn't need to do. And then I have a Khan Academy posted for you as well. Try the bookwork first. I will have a video made with the solutions to those questions, and then I want you to take a shot at the Khan Academy and see, can you solve all those problems? So how do I know when to solve using law of sines? You're going to look for a situation where you know a side and the angle opposite it. So you need to know both those pieces of information and then one other side or angle, and you can go solve for pretty much the entire triangle. And then for tonight, you've got your textbook and Khan Academy work. And that'll do us for this week. I'll give you the law of cosine stuff, but I'll let you have until next week to work on that. And then we've got our unit test next week as well. Talk to you soon, guys.